Hey folks, welcome back. This is Joel, and we will continue with our discussion on SDWAN. I think we are close to 11, 12 videos in. I did not plan to do so many, but now that we are doing, let's keep up with it and continue exploring more features of SDWAN, right? Um, okay, so in this particular session, I want to explore a very interesting feature of SD-WAN, which is the application-aware routing, right? It's probably there in every marketing material which you see for SD-WAN, but what exactly is it and how does it work? And we'll also try to demonstrate few things. Okay, awesome. That being said, let's go back to our whiteboard. So, like I said, we are going to be looking into uh, application-aware routing, right? So it's in short, it's basically called as AAR. Now, before we even talk about this, we have talked about the default, traffic behavior, right, in SD-WAN. So the default behavior, let's call it as the first one, is basically the ECMP, right, equal cost multipathing, which means if you don't put any policies, if you don't do any kind of extra configuration, by default, when the edges come up, they will come up with the, IPsec tunnels to every single, site, right? So it's going to be something like this. It's going to be a full mesh network. As a result, every single site will have IPsec tunnels to every other, or every vEdge will have IPsec tunnels to every other TLOC, of the other vEdges. So as a result, it's going to be more like a full mesh, right? So you might have probably from BR3, you might have probably say, I'm just giving an example. It might be like 8 or 10 tunnels, right? So you're going to have these tunnels, and all the traffic is going to be like kind of like load balanced across these tunnels, right? So that's your ECMP way of doing it, right? And that's the default behavior of SD-WAN. Now we also explored in our policies, we also explored as to how you can change the default behavior, right? By doing a little bit of tricks with your by changing some parameters, by defining policies, you can basically make your traffic pick a particular transport, right? You can probably say, pick MPLS transport, and make your say internet as your standby, right? More like a active standby kind of a fashion, right? All of this can be done by playing around with your policies. But don't you think the best option would be to kind of use a mix of both, right? Not just stick to one or two, but kind of go for a third option, which is going to be like a mix or a hybrid version, right? And that's the recommended version. The recommended way is to kind of like make sure that we use both our transports and don't keep one of them idle, right? Use both the transports, maybe for a critical app, right? Maybe for a critical app, use something like say MPLS, right? And for less critical, you can probably use something like internet, right? Don't you think this would be a very favorable and a better approach? Because by doing this, you would probably not be skipping any link or any kind of transport idle, right? Now, this is how you would do in a traditional networking, right? I mean, even in a traditional networking, this is what you would do. But SD-WAN kind of helps you. It kind of automates this process, I would say, and it takes one step forward in this direction by bringing in this feature, which is AAR, right? So let me just put it here. So this is where your AAR comes in. So what does this feature does? What this feature does is basically it has the capability to monitor, right? Monitor what? Monitor the path metrics. It could be delay, it could be jitter, right? These are some of the path metrics, right? You probably would have heard it before. Jitter, right? Jitter is basically making sure that even if there is a round trip delay, making sure that there are consistent round trip delays, right? Otherwise, the experience of the application is going to be bad. If the round trip delay at one instance is 5 milliseconds and the other instance is 10 milliseconds, then let's say you're having a phone conversation with someone or a video, it's going to appear very bad, right? So delay, jitter, and the other one being bandwidth, right? So all these are various metrics, right? So AAR, application aware routing, what it does is it can monitor these metrics for you, right, on a specific transport, and then it can monitor these metrics for all the transports, and what it can do is you can now define an SLA, right? You can define an SLA. Say for example, voice traffic. You have a certain SLA defined, consisting of these parameters, right? Now, if what SD-WAN can do is it can now choose the best transport which fits this SLA, right? Similarly, for video, you can define another SLA, right? So different applications you can define, different SLAs, and you can make SD-WAN pick the best transport that is available out there to serve your purpose, right? So that way, what you can do is you can make critical apps. You can give a particular SLA. Obviously, it's going to have a specific SLA, and the critical apps will probably choose a more, let's say, more efficient transport, say something like MPLS. Whereas if someone wants to connect to their Office 365, which probably doesn't have a very strict SLA, for that traffic, we can probably go and use something like internet, right? So that's the whole idea behind this application aware routing. Now let's obviously, go ahead and check out how we can basically go about configuring this. Piece which I also want to talk about along with this AR over here is, when we talk about these parameters, right, delay, jitter, latency, right, how do you kind of track this? How does SD-WAN actually monitor this, right? So that's where your BFD comes into picture, right? So your BFD basically plays over here. So you have BFD, right? The bidirectional forward detection, right? So how does this help? Is that we have two use cases for BFD in SD-WAN. The first use case is BFD is actually used to check the health of T-lock tunnels, right? The check the health of the remote T-lock, right? In case of my IPsec tunnels, that's one of the reasons. So whenever you go to any vEdge, if I do show BFD sessions, you basically get to know all the BFD sessions which are alive, and that's how SD-WAN is able to figure out if a particular IPsec tunnels is, should be set up, and if it is healthy or not, right? If it doesn't get the BFD health up, then it's going to pull the particular tunnel down, right? So that's one of the use case of BFD. The other use case is basically to do the same thing, which is monitoring, right? So the monitoring which is especially needed in case of my AAR, right, it's actually done by this BFD for you, right? Now, yeah, so I think we have covered all the theory part of it. Now I think we are good to go and start playing around, and let's look at the UI a bit. All right, so let's go down to my vManage. This is my vManage. Yeah, looks good. So you have the control up, all the edges are up, everything looks good. So let's go down to the monitor section, which is something which we have been using a lot of late. So in the monitor section, where do we go? So because we are talking mainly with respect to tunnels, let me probably take, I don't know, R1. Let's probably take R1 and let's go to the tunnel section of monitoring, right? So this is the tunnel section. You can see here. Excuse me. Let's click on tunnel. Right. So when you click on tunnel, you basically see all the tunnels. I just started my lab. I just turned it on just now, so that's why you can see all the tunnels over here coming up, right? Maybe if I reduce it to 1 hour, I think it will be better. See here, I've reduced it to 1 hour, so it's basically showing me all the tunnels, which are up over here, right? From R1, we have, I don't know, we have 6 tunnels, I guess, right now. But let's see, we actually have 8 tunnels, honestly. I mean, I think there are a couple of them which are overlapping here at the bottom. So yeah, MPLS ones, right? Anyway, so we have 8 tunnels, as you see here. And I think this is something which we have not seen before, right? We have not observed this. We have come to this page, but we have not observed the important part, which is, the jitter loss, right? And there should be one more, latency as well. So let's go to the right. Right, so you have latency over here, right? So there's latency, there's jitter, and there is loss, right? And you have this for all the tunnels, which what I mean by that is, on the left hand side, as you scroll to the left, so these are my public internet facing, or the tunnels which have the local color as public internet, and these are the ones which have the MPLS, right? So let me scroll down a bit. Yeah, so you have 4 here and 4 here, right? So these are the 8 tunnels, and okay, If I select this, you would basically end up seeing all the 8. I think that's the reason you were seeing 6 over there earlier. See, now you have all the 8 tunnels, right? So these are all the tunnels which are basically coming in from my R1, right, which is the headquarters router. And I just want you to spend a second, and look at, the values which are appearing here on the jitter, loss, and latency, right? If you look at it, probably the jitter looks to be somewhere in between 10 and 15. I would talk about the average. Loss, I don't think there is much. And as of now, in fact, yeah, I don't think there is much loss, right? And the other thing is the latency. Again, I see there is a bit of latency over here on the MPLS side, and you also have a bit on the internet side as well. But yeah, so these are the values, right? Just observe this. I mean, obviously I'm running it in a simulated environment, so this doesn't. I mean, I'm pretty sure in an actual environment it would be much worse. But yeah, so this is what we have as of now. And you can also see the same metrics per TLOC, right? When I say per TLOC, obviously it's per transport. You can see the average numbers appearing here, right? So it basically tells me that from R1 for MPLS, this is the average jitter, and this is the loss, and this is the latency, right? The number seems to be a little bad for my MPLS, whereas it seems to be comparatively less for MPLS. Sorry, for internet, right? Which makes sense. All right, so now let's get started. So I was talking about BFD, right? So we'll start by creating a BFD template, right, for all the vEdges, because BFD is something which is very important if I have to do anything in AAR. So let's start by creating a BFD template. Very similar to how we have created templates before. We will revisit this obviously later as well. But for now, let's go and do this. So when I do this, so obviously we don't have any templates. So I have to add a new template. And let's select the device, which is vEdge cloud. And when you do that, you get the BFD option here. Select that. Now, when you're doing BFD template, first let's go and obviously put in the name. So let's call it as BFD vEdge, BFD underscore. Or let's use the acronym which we have been doing, right? I think we have been doing vEdge underscore BFD, right? This template would basically go on all the edges. So let's keep it this way. Now, this is how BFD, right? So BFD probes are basically sent every second, right? So the path quality data, right, or the path quality metrics, basically all the jitter and all of that, right? It is basically gathered in intervals, okay? And we can define what intervals we want. Like by default, I believe it's going to be, this is in milliseconds. So by default, it is collected every 600 milliseconds, right? Over here, you can see. But let's probably change this. Let's change this to 10 milliseconds, which is, I'll have to put 10,000 here because it's in milliseconds, right? So 10,000 milliseconds is basically 10 seconds, right? So we have changed it to 10 seconds, right? So what happens is the BFD probes, right, which are which are used for collecting all this information, the path quality information, right? It is basically collected in intervals of 10 seconds, right? And the number over here, multiplier, right? It basically tells that we basically use the results from 6 intervals. Right now, the multiplier default value is 6, right? So it basically means that we are basically going to use the data which is collected from every 6 intervals, right? So just to recap, we are basically sending the probes every 10 seconds, and we are collecting, or we are basically gathering data, or we are basically gathering or using that data every 6 intervals, right? So every 10 into 6, which is 60 seconds. So every 60 seconds or every minute, we will be basically using the data or averaging it out so that we can then use it in our policies, right? Hope that is clear. That's the multiplier, and this is the polling interval. Now, there is also another part of the BFD configuration here, which is concerning to the T-lock liveliness, right? So I told you earlier in my diagram over here, I was telling BFD is used for two use cases. One is monitoring, which we already did. We have done the configuration for monitoring. But for T-lock liveliness, this is done by default. But if you want to kind of like put in some values over there, we can do that as well, right? So let's say we're gonna put in new color, right? And let's do this for MPLS, right? So we'll put MPLS. There you go. I have MPLS, and let's do the hello interval is going to be for, I don't know, maybe 500 milliseconds, right? Let's do that. And 500 milliseconds is what, 0.5 seconds, right? Every half a second. I think by default this is done for every 1 second, I believe, but we are changing it to 0.5 seconds, right? And the multiplier, again the same concept, right? It was 7 by default. Let's change it to 5, right? So multiplier basically tells you that you keep on collecting your BFD information, but keep on collecting and collect it for, in this case, 5 intervals, right? In the above case, you're basically collecting it for 6 intervals. So that's a use of multiplier. And path MTU, let's keep it on, right? So let's add this. All right, so let's save this. So I mean, let's not do it for the internet transport. Let's do it mainly for the MPLS transport, because we'll mainly be testing the failover scenarios using the MPLS, right? So I think that's good, right? So we have done the basic BFD configuration needed for AAR over here, and this is mainly for the BFD hellos, which are basically sent for checking the liveliness of T-lock, right? The remote T-lock on the tunnels. So let's save this. And now we will have to do a hectic task of basically going down to every single of my device and adding it. So let's start with the dual. Let's edit it over here. I'll probably show you how to do it for one and probably pause the video and do the rest. So you can see where you gotta do this is you need to go to the basic configuration. You'll find something called BFD. Where is it? Over here, right? So by default, it is using some default factory template because I said BFD is something important, right? Without that, your IPsec terms will not come up. So now we are changing this behavior and we're making it use this. All right. So that's where you do it. And let's update this. So this will probably take care of 2 of the devices. Let's hit next. Configure. All right. So while I had paused the video, I went and enabled the same BFD template for all the devices. You can also check here probably to verify. You can go to the feature templates, probably find the BFD. You can see BFD is over here, and you can see the number of devices which it is attached to is 6, right? So I've enabled it for all the 6 devices. Awesome. So now let's go back to our monitor and let's check out the metrics, right? Because it should have started collecting. So let's go to network and probably select, I know, R1. So on R1, we should basically be able to see so we should be able to see statistics here, right? So let's try to find where do we get that. I believe it should be under real time. Yeah, here you go, real time. And here you should probably search for app route statistics. Here you go. You have the option. Do not filter. Right. So you can see the statistics here for the various tunnels. Right. You can see the device IPs, the source IPs, the destination. Scroll to the right, the mean delay, right? The latency, the jitter, all of that, right? All of that information can be seen. Also, if you observe carefully, for every remote IP, you basically see there are 6, entries, right? Say for example, for 101 you see 6 entries, for 102 you see 6 entries, and what are the 6 entries? It's basically the 6 intervals, right? 6 BDP, sorry, why I said BDP? We have BFD intervals, right? The 6 intervals during which the data is getting collected via BFD. Sorry, again. Um, yeah, so this is how you have your data. This is how the data gets collected, and you can see the mean values appearing here. All right, now we can also check out the same values from the device itself, which is something like I think I already have it here. Yeah, you just need to run show app routes stats, local color. Let's change to MPLS, right? Let's be more interested with MPLS. So you can see by default the latency is around, I see values of 50s, 60s and 70s, right? It's around that. I see 59, 52, yeah, and there's one path where it is around in the 70s. But yeah, it's probably not more than, anywhere it's not more than 80, right? The worst case is 80, 81, right? So that's the latency, average latency as of now on the MPLS side. You can also check the same thing on the internet side, right? So you can see for various paths, it's again somewhere between 20s, 30s, and one of the paths seems to have around 60, right? Again, this is since I'm doing this on a simulated environment, it might be a little unpredictable as to why one or two paths have a very high value, because of the different operating systems and different interfaces which I'm using in this emulated environment, right? But I'm pretty sure it's going to be very, very much predictable or very closer to each other in an actual environment, right? Anyway, so it's very important to baseline of this sort, right? A very important baseline before you can go about doing application aware routing. Now, since we have a baseline here, we can go about creating, our policy. So let's call this as so let's start the first policy, right? So I would want to have application aware policy where it's going to be for voice traffic, right? For voice traffic, uh, and because it is voice, I want to mark the voice traffic with a particular DSCP value, right? A bit of QoS has to kick in, which is going to be DSCP. Let's say we are going to mark it as EF, right? This is I mean, I'm not going to explain this. This is like fundamental QoS marking, right? So DSCP EF will be the value which you are going to use. And now when it comes to loss, latency and jitter, so we have to define the SLA, right? So this is where we define the SLA. All right, so for loss, let me just write it here. I think it's better if I kind of like create, this is going to be loss, and latency, and the other one is going to be what? Jitter, right? So for voice, I'm going to sorry. So for voice, I'm going to have a loss of. Let's start with latency. Latency, I have seen we have around 50 to 80 milliseconds, right? So probably let's define it to be I don't know, maybe 100 to be safer, right? So 100 milliseconds will be the latency which we are defining for the SLA. The jitter and the loss, let's look at the values again. I mean, I keep forgetting the values. So if you look at the values here, let's look at the MPLS side, because I want to prefer MPLS for this. You see the jitter is somewhere, yeah. So jitter I see 15 and all of that. Just want to be sure that we have all the right values. So how much do we define the jitter as? Probably 18. I also see 18, 15, 20. I see 20. Yeah, I think 20 is good. It's not more than 20. So let's probably define it to be 20, right? The jitter to be 20 milliseconds, and the loss currently, how much do I see? Let me just run this again for MPLS side, right? For the MPLS side, give me a second. Yeah, for the MPLS side, I see the loss to be 0 everywhere, and there is 1, right? So worst case, let's go and define it to be, I don't know, 2, probably 2% loss, right? So these are going to be my values for my MPLS, sorry, for my voice, and like I said, I would want to prefer, let me use a different color, I want to prefer MPLS as my transport for this particular type of traffic, right? Similar is the case for the second guy, who is going to be my let's say some kind of business applications, right? Like for example FTP, right? FTP is a business application, right? Now the loss here, I would probably go and define, since I want to prefer, I mean I don't want to prefer anything, I would want to SD-WAN decide it for me, right? Whichever it wants to pick, right? Whichever transport it wants to pick, it's going to pick here. So I'm going to not define a specific transport here. But coming to the values, probably I can play around with the values. I can say something like, say, 3% loss, right? And the latency, I can probably define it to be, say, something like I don't know, 120 milliseconds, right? I'm just playing around with the values, right? Nothing very, and the jitter probably has something like 30 milliseconds, right? And the last use case I want to do is something like default, right? So any other traffic other than voice, other than FTP, if there is any other traffic, right? The matching will be obviously, or the classification will be done as DCP 0. The number will be 0 for that, DSCP 0, and so here obviously I'll probably put a higher loss, maybe like 5%. Um, and I want to, yeah, prefer internet here. So here it's going to be internet. So for each of these types of traffic, I want to prefer a specific, transport. For the first one, internet. For the last one, sorry, for the first one, MPLS. Here, internet. And for this guy, obviously, I'm gonna allow SD-WAN selected for me, right? Now coming back here, let's probably put a very big value, which is said something like 200 milliseconds here, right? The latency, very high latency, and then the jitter also something like 50 milliseconds jitter, right? So there you go. So we have set up our use case. So now it's only, we just need to go about configuring this. All right, now that we have defined our SLA, let's go about creating this, which means we will go to my policies. It's going to be a systematic process. Let's follow that, right? So we go to policies, let's go and create a list. We basically need a lot of lists for doing this, so let's do that. So we go down to the list. What list do we create first? We will have to create our SLA classes, right? So you go and select SLA class here. Now what is my first class? Let's say I want to create a SLA class for my voice. So let's call this SLA underscore voice, right? And this loss which we have defined, okay, I keep forgetting, it's 200 milliseconds and 20 milliseconds, right? Hope I remember that. So where's that? Let's go back. So this is going to be 2%. The latency is 100 milliseconds, and the jitter, what we have defined is, I believe 20, right? Hope it's correct. Yeah, 220. Awesome. So let's add this. Similarly, we have to create for the rest of the two guys, which is SLA underscore BIS. So for BIS, we have defined it as, let's go back and check the numbers, 3, 120, and 30, right? So it's going to be 3, 120, and 30. Right? We're just defining the classes, right? Nothing other than that. The third one is your SLA for the default, right? Basically all the other traffic which doesn't fall under the first two. And for that, we have defined 5, 250, right? These numbers, please don't go with these numbers. These are just because it's an emulated environment, the numbers are very worse. I would say basically in an actual environment, you will have better values, right? Anyway, 5, 250. So let's go with 5. Let's go with 250. Okay, hope that is correct. 5, 250. Yep, that's good. So we have done this. We have done the SLAs. Now, which means we have taken care of what? We have taken care of this part. Now we need to take care of this part, right? Where we have to match certain things. So in this case, we have to match the DSCP EF value. Here we have to do DSCP 0 and FTP. So how do you do that? right? So yeah, so before that, I hope we have the application visibility turned on. We did that in the previous video. If you have not, check the previous video and enable the application visibility. But since we have already done, I'm not going to do that here again. We will directly go down to my application here, right? Remember we had done this whole, denying apps and all of that, right? Okay. So now what we'll do is first let's define the FTP part, right? Because that's something which we might need. So let's define an application called FTP for business. The rest of the two is basically matching DHCP. That we can do it later. So here we will basically say FTP. Will that work? FTP. That is not seen. I think I need to write it as file transfer. There we go. File transfer protocol and file transfer data. Select both. And let's add it. Right. So you have defined an application called application for business needs, right? Cool. So let's go back to my central policy, sorry, the centralized policies now. Now, once we are on the centralized policies, let's add a policy, right? We have already done this part, so we can go to the next. We are not going to do control policy, so let's go to the next. Here you see we have your application aware routing, right? This is where we have to build our next step, or we have to do the next step, right? So let's go and create a new policy here. All right, so here let's go and define a name, which is application aware routing. Let's call it as application aware routing policy, right? So let's copy this down to the description. Now, next is we need to obviously go and add a sequence type. So here when you add a sequence type, add a sequence rule. So we'll take care of the first one, which is my voice, right? For voice, the condition for matching will be the DHCP, right? I have been talking about DHCP. Now, if it is DHCP or is it EF, right? EF, I'm going to use 46 for that, right? That's EF basically corresponds to 46. Again, that's basically textbook QS. Just you'll have to check that out, right? I'm gonna change this to 46. And if it matches, if traffic matches this, what do? The action part is in the action, you see the option. I need to select the SLA class. What is the class? It's your voice. Right now, this is where you define your preferred colors. Right, so you can define the preferred colors. In my case, I want MPLS to be chosen here. So I'm going to select MPLS. Right, you can also define a backup this thing, right? So I believe that should be somewhere here. You can also define a backup preferred color, right? In my case, I'm going to use the backup tunnels also to be MPLS, right? Because there could be multiple MPLS tunnels, right? So I would basically want only MPLS, or basically I would want even the backup, tunnels to be preferred, and the backup tunnels also I would want it to be MPLS. I'm going to select that. Right, you can obviously change it to internet or whatever based on your needs. Right, so once I save that, this is what you get. Right, so we have created one rule. Scroll to the top. So we have identified this traffic, and we have put it in a particular category called SLA voice, and we have preferred the transport which we need. Similarly, let's go to the next one, which is my so here now I can select my application, because for business needs I'm basically not doing I'm not marking it using DHCP. Rather, I'm using the applications which I've defined earlier, which is basically FTP in my case. On the action side, again, the SLA class will be the SLA BIS. Selecting here, and here you see I will not basically select a preferred color, because I would want SDWAN to pick it for me. Whichever is matching my list, whichever comes first, it is going to pick it. Select. And another rule for the third use case, which is let's go top. So here for the third one, again we'll have to match it based on DHCP, because it's a default value, right? Default, I'm gonna select 0. And the actions, on the action side, again we have the SLA, which is gonna be my default, and the preferred color is going to be internet actually here, right? Remember, I have used internet. I'm not cooking this up. You can just have a look here, right? So I'm basically using internet as my preferred for this particular use case. So let's use public internet. Should be somewhere here. There you go, public. Even the backup route also, I would wanna backup color also would be SLA preferred color would also be my public internet for this one. You might get a question as to why I'm selecting both to be the same. The reason is because it's going to be multiple tunnels, right? It's not just one tunnel. There are going to be multiple tunnels for the same color. So I'm just preferring this so that one tunnel fails, the other one, the next best one would be used. Okay, so let's save this. Okay, so there you go. So we have basically selected everything which we want. We have created the policy, right? Now once we do that, let's save this. And let's go to the next. I don't think we have to do anything here. Let's go next. So here under the application aware routing, we'll have to select the site list and the VPN list. For site, I'm basically going to select all sites, right? And for VPN, obviously it's going to be VPN 10. We have just one service side VPN, right? There you go. That is done. Let's add this. And I think we are very close to finishing it. Let's save the policy. Okay, I think I need to write the name here. So application aware routing policy, right? I think I've used the same name everywhere. It's fine. Let's save this. There you go. It's going to be saved, right? So now that we have that, the only next step is basically going and activating this, right? Let's see where this policy goes. So when I activate this, see, it is basically going to the vSmart, right? It's not coming to the devices, so it's a centralized policy. Right? It's a centralized data policy. It's a form of centralized data policy because we are matching based on the data packets, and we are basically telling it what to do. We are basically telling which tunnels to use, right? So it's like a centralized data policy, right? Very similar to what we did earlier in the previous video, which was also centralized data policy. Right now it's already applied. So let's go and check if that works. So let's go to my, let's say something like BR1-1. And up here, let's check show policy. Show policy, I believe it's from vSmart. There you go. You can see all the three SLAs are visible here, right? That looks good. So the policy has arrived from the vSmart over here. Now it's all about testing, which means let's go to my testing place, which is the monitor over here. Under monitor, let's go to network. And under network, we are basically going, let's select say BR3 this time, right? So on BR3, let's probably go down to troubleshooting, simulate flows, and what do? Let's select VPN 10. Let's select this to the gigabit 2.10, and the source IP is going to be, yeah, perfect. Destination is something like we are basically talking to the headquarters, so it is 172.16.13.1. Now the application, let's keep it as is, let's go to the advanced options here. Right now, this place you can also simulate the types of traffics, right? So for example, for my voice, I need the DSCP value of 46. So now I'm simulating my voice SLA, right? This looks good. So now let's hit the simulate button and let's see what's happening. You can see here, it is selecting the MPLS path, right? The reason is because of our policy. We have explicitly defined, right? Any traffic which comes with DSCP marked as 46, it is supposed to select the tunnels which are MPLS, right? We have preferred it. right? That's why. And the MPLS tunnels as of now, they are meeting the requirements. That's why, you can see them over here. Let's now switch to probably DSCP value of 0, right? DSCP value of 0 is default traffic. So it should switch to internet now. See, we can see that as well, right? Application aware routing is working, right? Based on the traffic, it is able to figure out which tunnels to use, right? Which paths to take. Okay, let's continue this. Let's now change the application. Where is the application? Let's change the application up here to FTP, right? Because for the business side of it, remember we have said that if there is a data coming for this particular application, we will have to, we will have to what? I mean, it's going to choose whichever is best, right? So it's going to choose whichever is best. So let's do that. So whichever meets the requirements, right? So let's see. There you go. So all these 4 tunnels met the requirements, so it is doing ECMP between all these 4 paths, right? So that is for your FTP, right? So we have demonstrated for DSCP value of 0, DSCP value of 46, and the FTP, the 3 use cases which we had, right? Now what do we do? Let's also do something interesting. Let's probably remove the application which is FTP. Like, what if we put in some traffic which is not matching any of the 3 cases, right? If it is, say, we have taken care of 46, we have taken care of DSCP 0 and FTP. So let's put some DSCP value as 3, and let's observe what happens. There you go. So it basically goes back to doing ECMP, for these along these 4 different tunnels, right? And that's why you see this, right? So application aware routing will basically work for the traffic which you define in the policy, right? So we define for 3 policies. So for those 3 policies, it works as is. Whereas for the rest of the traffic, right, which doesn't fall under the policy, it goes back to doing the ECM. Now the next part. Okay, so next part is something interesting. I'm not sure again it would work. I'm just trying it out myself for the first time. So hold on. So what we are doing next is pretty interesting, right? So I've got myself, what you see, a WAN simulator here, right? So earlier you would have seen this particular box was not available here, right? I've added a WAN simulator which can now simulate some kind of, latency, delay, and all of that, right? The whole idea here is I want to kind of deteriorate this link to see if application aware routing will will do a very good switchover, or how does application aware routing play with some kind of a failover? Does it have some kind of a failover, right? So that's what I want to investigate. So I added a WAN simulator here, using which I can obviously change my values, right? This is pretty simple. I think it's a open source a network emulator tool over here, right? I've just connected it between my R2 and my MPLS, right? So it is basically getting itself it is attaching itself to the MPLS circuit of my R2, in fact of my R1 as well, right? So it's adding itself to the headquarters side and the MPLS circuit, right? And by that, what I mean is, so if I let's see, give me a second. All right, so let's go to BR3. Let's keep that tab open. So let's go to BR3 here, admin, and let's run the same command which we did earlier, show app route, right? Stats probably, and the remote system, say for which one? Say the R1, which is 172.16.0.11, right? This is the current value. This is the current values which are there over here, right? So I think one is for the public internet and other one is the MPLS, right? These are the current values. Hope the values which I have set are not worse than this. Yeah, okay, looks good. So this is my current values to the tunnels which go from BR3 to R1, right? On average, I would say on the MPLS side, it appears that I have a latency of 50 50 to 60, whereas on the internet side I have between 20 and 35, right? Which is all right. Now what I'll do is I'll use this tool which I have, the WAN emulator, and let's try to failover. And what I mean by failover is, let's probably introduce some kind of a delay. Uh, so we want a round trip delay, right? Because this whatever values we have talked about, these are round trip delays. So we want to introduce some delay. And in order to do a failover of the case number 1 and case number 2, I will have to probably put something like 150 milliseconds, right? Because here it is 100 milliseconds and this is 150, so sorry, 120 here. So I need to somehow change the round trip delay from the average value which appears here to be 60. I would want to change this to 150. All right, so let's try that. So I have the WAN emulator here, right? So I'm going to go and change the delay to, I'm going to add a delay of 45 in each direction, right? And let's also add some kind of a loss as well. So you see there is 2, 3 over here. So let's say the loss of around 4%, right? That would be cutting close for the other one. All right, so let's probably make it like 4% loss and probably like 150 milliseconds, so that both of these switch over, right? That's what I want to check out. So let's do that. So let's go to, want to change to asymmetric mode. No, sorry, I think I clicked something else. Anyway, so let's go and change the value here, the delay. Let's change it to, like I said, let's add 45 milliseconds on each direction. Let's do that. And let's also add a, was it loss? Yeah, let's add a loss. Probably here. Let's add a loss of, how much is that? So, let's add a loss of around 6, no, I would say 4. 4 is good, right? Yeah. So now that you have added that, you can see the values changing here. We should be able to see the values changing over here, right? So earlier it was this, but now you can see it should increment slowly. You can see the values, the intervals, the first 3 intervals are already captured, right? On the internet side, nothing is changing because we are adding the changes only on the other side, right? And you see the values are becoming 150, right? The 4th interval is also 150 now. This is the reason why we had selected that, right? When we are creating the BFD template, we had selected 6 intervals, and these are the 6 intervals. So after the 6 intervals are completed, only then the switchover will happen. See, now the 6 intervals are completed, and the current latency is more than, it's 150, right? And as per our policy, we had defined it to be 100 or 120. So both of these should now switch over or fail over to a better transport. Let's see if that is happening, which means let's go back here and let's remember, I should have probably had a screenshot, but anyway, let's go back to this and change the DHCP to 46 now, right? And earlier, remember when we did this, it was using MPLS, but this time, let's see what it uses. There you go, it has switched over, right? Earlier, remember, if you want, you can also go back to the video and you can check. When we were using the DHCP 46, it was using MPLS because that was the preferred color, right? And it was meeting the SLAs. But then now, since we have deteriorated our link, what we have done is we have gone ahead and deteriorated our link by adding a WAN simulator here, right? So this basically introduces delay, jitter, and all of that. So we have deteriorated this link. As a result, the MPLS transport for my headquarters is completely deteriorated, right? As a result, it is now not using MPLS, rather it is using public internet, which is a better transport at this point, right? We could also probably get to see that on the portal here, probably under, if you go to monitor. The thing is highly unlikely we will get to see it now. I'll tell you the reason as well. So if you go to the, let's say we select BR3 and we go to something like tunnel, let's go to the tunnel, and here ideally we should start seeing some kind of a switchover happening, but I'm not very sure if you'll get to see, because let's select 1 hour as the time gap, right? So Yeah, so this is what I was saying. You can probably go down to the real time and you'll be able to see the switchover of the tunnels happening. Meanwhile, we also need to check the failover of the other one, right? Probably I forgot to do that. We can check that out as well. So let's check the failover for going back to BR3. If I check the failover for the other SLA which we have, check that. So it's VPN 10. This is going to be 10, and the destination is obviously the headquarters. Um, so we did, I believe we did 46, but I think we did not do the FTP, right? So we can check that. So for application, we can select FTP, and we should probably be able to run. And since the MPLS tunnels, MPLS transport violated the, SLA which was set, it is no longer using MPLS. It is using only public internet, right? So that was basically what I wanted to show you guys as part of this use case. Pretty straightforward, right? What we did was, to summarize, what we did was we kind of looked into application aware routing, where we we are kind of like moving away from the option number 1 and 2, which is visible here, which is but the default traffic policy of SD-WAN is, it basically uses the ECMP, right, equal cost multipathing. So it's going to have a lot of tunnels in a scenario, and when you have a lot of tunnels, it's very difficult to monitor all the tunnels. The operations becomes difficult. So generally what people do is they go for the option 2, which is more like using active and standby, right? And for a minute, forget about SD-WAN, right? This is the case in any kind of WAN, right? You use some kind of a MPLS transport for as a on an active fashion, and then internet for a standby fashion. Now, right? So that's generally what is done. But what we started to do with application aware routing is that, somehow making sure that we don't have a lot of tunnels, right? We don't have probably tens of parallel tunnels going from every single TLOC to every other TLOC. And how do you do that? Now you can define SLAs, right? With application aware routing, you have BFD probes which are deployed to go and collect information from your tunnels, from your existing tunnels, to figure out what is the jitter, what is the latency, right? What is the loss? And once you have determined these values for a predefined interval, so that's where the intervals come, right? So you define it for in 6 intervals, 7 intervals, depending on whatever you have set. So once you have determined that, now the tunnels can switch over, right, if a particular SLA is not met, right? So that's where what we did was we defined 3 different SLAs for our enterprise, let's say, for a minute. And the 3 SLAs were for voice, for business applications, and for default traffic. And for voice, we ended up preferring MPLS. For business applications, we did not give any preference. We just said go ahead and use whichever tunnels comply with our SLA. And for default, we explicitly said use internet, right? So now we get the flexibility of using multiple tunnels, yes, but at the same time, we also get the flexibility of not having all the tunnels which probably don't have the required SLA. So we have multiple tunnels, but at the same time, we have only those tunnels which comply with our SLA, right? And then at the last, what we did was we kind of introduced some kind of a WAN simulator here. If you see this, probably this is something interesting. You can use this in other tests as well. So you can introduce a WAN simulator here, which will kind of add delay and jitter and all of that, right? So we ended up adding a delay of 45 milliseconds, which roundabout kind of created a delay of close to 150 milliseconds here. And as a result, what we did was since the 150 milliseconds delay is kind of violating the SLA which we had defined for voice and business applications, we started seeing that the tunnels which were used earlier, MPLS was used in both the places, but after this experience, after changing this, the tunnels started switching to internet, because it did not find any MPLS tunnels which could carry the traffic at this particular SLA, so it went and switched it for us, right? So that was the intelligence which SD-WAN brings to the table, right? And that's a very interesting feature, which is your application aware routing, right? So thanks for watching, guys, and do tune in and continue watching more videos on SD-WAN. Thanks a lot. Have a good day.